Welcome to Study Loop.
Okay, so we know the magnetic field can be equal to mu 0 I over 2 pi r. So mu 0 is the permeability constant, okay, which is equal to 4 pi times 10 to the power of negative 7 Tesla times meter per ampere, okay? And then we have BP, which is the magnetic field at point P, is equal to negative mu 0 I1 over 2 pi r1 plus mu 0 I2 over 2 pi r2. And then we have mu 0 over 2 pi times I1 over R1 plus I2 over R2. And all this is because the current is flows toward right in this case. So we need to use a negative sign here. And then we know that I1 is equal to 10 ampere, which is the current that was flows toward right. And the current that was flows upward is equal to 12 ampere. And we know the vertical distance given as 8 centimeter, which is 0.08 meter. And the horizontal distance is 15 centimeter, which is 0.15 meter. So therefore, we can plug in back into the equation. Then we have the magnetic field at point P is equal to 4 pi times 10 to the power of negative 7 Tesla times meter per ampere over 2 pi. And then times, I forgot a negative sign here. Sorry about that. And then times 10 ampere over 0.08 meter plus 12.0 ampere over 0.15 meter. And this will give us the magnetic field at point P is about negative 4.1 times 10 to the power of negative 5 Tesla, which is negative 41 micro Tesla. And since it's negative, that means the direction of the magnetic field at point P is into the page. Because we can use the right-hand rule to examine, okay? And if you use the right-hand rules, you'll find out the direction for such values is into the page. So therefore, the magnetic field at point Q should be in the opposite direction. Let's say BQ. Since it's in opposite direction, that means it's 41 micro Tesla, okay? So they have the same magnitude, but the opposite direction. And the magnetic field at point Q is having a direction that is out of the page, since it's positive. And the magnitude for the both magnetic field at each point should be just 41 micro Tesla, okay? So for question B, so now the current start flowing toward left, and this is the equation we have for the magnetic field at point P in this case, which is eventually we have mu 0 over 2 pi times I1 over R1 minus I2 over R2. So all these variables is the same compared with the previous question, okay? So we can just use the data from the last question to determine the magnetic field in this case. So we have BP is equal to 4 pi times 10 to the power of negative 7 Tesla times meter per ampere over 2 pi. And then times 10.0 ampere over 0.08 meter minus 12.0 ampere over 0.15 meter. This will give us the magnetic field at point P in this case is about 9 times 10 to the power of -6 Tesla, which is about 9 microtesla. And since it's positive, that means the direction of the magnetic field at point P is out of page. And we know point Q, the magnetic field at point Q will always have the opposite direction when it compares with the direction of the magnetic field at point P. So therefore, the magnetic field at point Q, BQ, should be equal to -9 microtesla. And the direction of -9 microtesla is just simply equal to, into the page, according to the right-hand rule. So therefore, both magnetic field has the same magnitude, which is 9 microtesla. And these are the answers for this question.